Have you ever, late at night, looked up at the sky and wondered what it would be like to leave it all behind, to drift away from the gentle glow of our Earth, past the moon, past the planets, and to sail toward the stars themselves? The idea of interstellar travel carries such a romantic pull. It feels like an ancient dream, as if written in the human heart long before we ever built our first ships. The thought of reaching another world, of touching distant suns, is like imagining stepping into a storybook written in light. Yet reality, as it often does, has its own quiet truths. The cosmos is not only beautiful, but vast beyond words, so vast that our greatest journeys so far look small against it, like a child's footsteps on the edge of an endless desert. Let us take, for example, the Voyager 1 spacecraft. Launched in 1977, it is now the farthest human-made object from Earth, a silent traveler carrying golden records of music and greetings from our species. It speeds through the dark at an impressive pace by human standards, about 10.5 miles per second. To us, this sounds fast, faster than any jet, faster than bullets, but compared to the grand stage of the universe, it is like watching a feather float across the sea. If we asked Voyager to take us to our closest stellar neighbor, Proxima Centauri, the journey would last 74,600 years. Imagine that, more than 70 millennia. Civilizations would rise and fall. Languages would be born, evolve, and vanish. Entire forests might grow and disappear again. And all the while, Voyager would still be on its lonely voyage, moving slowly across the gulf of space. This is the gentle paradox of the stars. To reach them with our current technology is like trying to walk barefoot across a continent of oceans. And yet, human imagination does not stop there. We dare to dream bigger. We imagine ships that can travel at nearly the speed of light, 186,000 miles per second. Numbers so enormous they almost lose their meaning, like trying to count grains of sand on a shore. It feels impossible, perhaps even absurd. And yet, let's imagine. Let's allow ourselves this vision, if only for a moment. Wouldn't that solve the problem? Wouldn't a light-speed ship carry us across the galaxy in no time at all? Even if we could reach such a velocity, leaving the Milky Way itself would still take about 100,000 years. 100,000 years of travel, even at the fastest speed nature allows. The stars themselves remind us. Distances in the cosmos are not like distances on Earth. They are oceans layered upon oceans, so deep that even beams of light must take lifetimes to cross them. But what if we dared to dream further? Beyond stars, beyond galaxies, to the vast cosmic landscape itself. That is where an even deeper mystery awaits. For out there, between the shimmering islands of galaxies, something strange has been found. Something so immense, so unexpected, that it challenges our very understanding of how the universe is woven together. It is a place not filled with stars, nor galaxies, nor glowing dust. It is a place defined by its absence, a hollow of unimaginable proportions. Astronomers call it a void, and not just any void, but one of the largest ever known, discovered in the year 2013. Before we speak of its size, take a moment to steady your thoughts, to breathe gently, because this is no ordinary emptiness. It is an abyss in the fabric of the cosmos itself. This is where our journey begins. Tonight, I invite you to drift with me, slowly and calmly, as we follow the trail of light and thought into the heart of this great cosmic mystery, a journey not of engines and rockets, but of imagination and wonder. So close your eyes if you wish, or let them rest softly. Feel the quiet rhythm of your own breathing, like the steady pulse of the universe itself. Together, we will take the first step beyond our familiar skies and wander toward the great unknown. Let us stay for a moment with Voyager 1. The lonely traveler we left adrift in the cosmic sea. Picture it, a small machine, no larger than a family car, wrapped in golden panels that glint faintly when touched by sunlight, though now it drifts where even sunlight fades. Its antenna points back toward Earth, whispering messages across billions of miles. Each signal takes more than 20 hours to arrive, crossing the void like a fragile echo of humanity's voice. Voyager 1 moves at 10.5 miles per second. To us, it is a record holder, a champion of speed. Imagine standing on Earth, where the fastest planes cross continents in hours, and the fastest bullets cut the air in a heartbeat. Compared to those, Voyager feels like a miracle. But out in the language of stars, it is barely crawling. Think of the Milky Way galaxy as a great island of light, its spiral arms stretching 100,000 light-years from end to end. Voyager's speed, though dazzling to us, is like watching a child take a single step in a vast cathedral. One step, then another, while the ceiling arches far beyond sight. Now imagine the journey to Proxima Centauri, our nearest star after the Sunday. At Voyager's current pace, the trip would last 74,600 years. Let that number linger for a moment. If we began the journey during the age of early human cave paintings, when ancestors traced animals on stone walls with firelight, the ship would still be far from arriving today. If we launched it during the rise of ancient empires, it would still be crawling along in the darkness, with most of the journey yet to go. 74,000 years is more than just a span of time, it is the lifespan of entire civilizations. The pyramids would rise and weather away. Great walls would be built stone by stone, only to crumble centuries later. Languages would bloom like flowers, then fall silent. And yet, Voyager would remain steady, indifferent to our brief stories, carrying its own slow heartbeat through the stars. There is something humbling in this. It tells us that the universe is patient where we are not, that the cosmos moves on scales so immense that our proudest achievements look like sparks in the wind. And still, the dream persists. We look at Voyager and think, perhaps one day, our ships will not crawl but soar. But the truth is this: with our current tools, even the closest star is impossibly far. Our rockets burn brightly, but soon sputter out. Our ships glide, but they cannot outrun the clock. The vast ocean of interstellar space remains, for now, an unreachable frontier. And yet, the dream is not extinguished, because to imagine is already to travel. To close your eyes and picture what lies beyond is to take the first step toward it. That is why stories of faster ships, of light-speed journeys, keep returning to us. They are more than fiction. They are whispers of possibility. So let us hold this paradox in our minds, that we have built machines capable of leaving the solar system, yet they remain slower than drifting leaves on a cosmic river. That our closest neighbor star glows in the night sky, near enough for us to name, but far enough to remain forever beyond our reach, at least for now. This tension between dream and reality is not meant to discourage us. Instead, it invites us to see the universe as it is: vast, mysterious, and patient. It tells us that to travel among the stars is not only a question of speed, but of time itself. So, let us not hurry. Let us drift gently with Voyager, knowing that in its long, quiet journey, it carries something precious. The reminder that even the slowest step can still be a beginning. Now, let us stretch our imagination a little further. If Voyager 1 moves too slowly, what if we built a ship capable of something far greater, something almost magical? Imagine a craft that could glide across the universe at nearly the speed of light itself, 186,000 miles every second. A number so large it slips away from us, like trying to hold the ocean in your hands. At first, it feels like the answer. Surely, light-speed travel would open the doors to the galaxy. Surely, we could leave our fragile solar system behind and explore the Milky Way's glittering arms in a single lifetime. But here, the cosmos reminds us again of its scale. Our galaxy, the Milky Way, is enormous, 100,000 light-years from edge to edge. Even if you raced at the very limit of speed, carried on a beam of light itself, it would take 100,000 years to cross from one side to the other. 100 millennia longer than recorded human history. Entire epochs of life, compressed into a single cosmic journey. Pause for a moment and imagine what that means. To travel the Milky Way is to travel through time as well as space. The civilizations that send you on such a journey would be long gone before you ever reached the far side. Generations would rise and fall, and the galaxy itself would change. Stars would be born, others would fade, and some would explode in brilliant supernovae. Even the dream of light-speed travel does not dissolve the distance. Instead, it reveals just how vast our home truly is. Our galaxy is not a neighborhood, it is a continent of stars, stretching far beyond the imagination. And beyond the Milky Way lies more still. Other galaxies, other realms, separated by gulfs so immense that even light struggles to bridge them. It is here, when we dream not just of interstellar travel but of intergalactic travel, that a new and deeper mystery begins to unfold. Because between these great islands of stars, astronomers have found something strange. Not fullness, but emptiness. A void, an absence so large, so profound, that it reshapes our very understanding of the universe. But for now, linger with this thought, that even if we mastered light, the stars would remain distant companions, twinkling from across an ocean that humbles us. The dream is not gone, it is simply transformed. It asks us not to conquer space, but to marvel at it. Not to rush, but to rest in the wonder of the journey itself. So let us keep moving forward, gently. Beyond stars, beyond galaxies, toward the edges of mystery. Up until now, our thoughts have lingered on stars and galaxies, bright islands of light in the dark sea. They feel eternal, steady, dependable. But what lies between them is just as important. Between those glowing clusters stretches a great cosmic fabric, sometimes thick with galaxies, sometimes nearly bare. And it is in this space, this in-between, that astronomers stumbled upon one of the most startling discoveries of our age. In 2013, while studying the distribution of galaxies around us, a group of astrophysicists noticed something that should not exist. It was not another star, nor another cluster, but the opposite, a colossal absence. Imagine, for a moment, a desert that stretches farther than your eyes can see. No rivers, no trees, no life, only empty horizon upon empty horizon. Now take that image and expand it beyond comprehension, multiplying it by billions. This is what the astronomers found. A void so vast, so hollow, that it seemed to break the very rules of how the cosmos is supposed to be arranged. This was not just a slightly thin patch of space, the way a meadow might thin into bare rock. It was a region, unlike almost anything else known, a bubble of near-nothingness, where galaxies and stars are far fewer, where the universe itself seems to have stepped aside and left a yawning hollow. The scale is almost impossible to imagine. This void is so large, light would take nearly 2 billion years to cross it. If galaxies had filled this emptiness instead, you could line up more than 20,000 Milky Ways side by side, and they would still fit inside. A hollow, vast enough to cradle countless universes of imagination. But perhaps the most haunting part of this discovery was not its size, but our place within it. For the data suggested something eerie, that our very own galaxy, the Milky Way, lies close to the center of this emptiness. We are not standing at its edges, peeking in. We are nestled within it, like a lone lantern glowing in the middle of a cavern. What does it mean to live at the heart of such a void? Could this peculiar position change how we see the universe? Could it alter the very laws we believe to be constant and universal? If space is not the same everywhere, then perhaps the truths we hold about the cosmos are only local whispers, not universal songs. Scientists call this mysterious hollow the KBC Void, named after the astronomers who first described it, Ryan Keenan, Amy Barger, and Lennox Cowie. For many in the scientific community, its discovery was like pulling a thread in a woven tapestry. Suddenly, The fabric of the universe seemed less uniform, less predictable, and so the questions began to deepen. What is this void really? Why does it exist? And most of all, what lies beyond it? Is the universe outside richer, denser, stranger than what we know inside? Might it be governed by different rules, different balances of gravity, matter, even time itself? We cannot yet answer these questions. But sometimes, the mystery is more soothing than the answer. Sometimes, knowing that we live inside a cosmic hollow is enough to remind us how delicate and special our vantage point is. We are like children gazing outward from the quiet heart of a cathedral, not yet knowing how far the ceiling rises, or what wonders wait outside its walls. And so, our journey drifts onward. From dreams of light-speed ships to the silent revelation of a universe filled not only with stars, but also with silence, immense, unshakable silence. To truly appreciate this discovery, we must pause and let the scales sink in. The KBC Void is not just an empty pocket in space. It is one of the largest known voids in the universe. Imagine standing at the shore of an endless ocean. No land on the horizon, just water stretching forever, merging with the sky. That same feeling of endlessness comes when we try to picture this cosmic hollow. It is a region so vast that even light, moving at its ultimate, unbreakable speed, would need 2 billion years to cross from one end to the other. 2 billion years longer than multicellular life has existed on Earth. Longer than the continents themselves have been in their present shapes. If this void were filled with galaxies instead of emptiness, more than 20,000 Milky Ways could line up inside it, side by side, stretching like pearls across a dark necklace. 20,000 galaxies, each one holding billions of stars, planets, and perhaps even life. And yet, this is not a silent void in the way we might imagine. It is not completely empty. There are stars here, scattered like faint lanterns in a vast mist. There are galaxies, too, but fewer, about 20% fewer than in the denser regions of the cosmos. To the human mind, 20% might sound like a small difference, but on the scale of the universe, it is immense. It is the difference between a forest thick with trees and a lonely clearing where the branches thin and shadows deepen. What makes this void truly unsettling is its defiance of the rules. According to the cosmological principle, the universe should look roughly the same no matter where you stand. On large scales, matter should spread itself evenly, like cream stirred into coffee. But the KBC Void is not a small ripple, it is a vast canyon in the fabric of existence itself. Its existence whispers that the universe is not as uniform as we once believed. For us, nestled near its center, the void is more than a curiosity. It is our environment, our vantage point, our cosmic home. It surrounds us, shaping not only our view of the stars, but perhaps even the way we measure and understand the universe itself. This is the paradox of living in a void. We cannot see its boundaries directly, yet we are cradled within it, like travelers in a balloon, carried by winds too large to notice. From our tiny world, we look outward at galaxies near and far, and we assume they reflect the truth of the whole. But what if the whole is stranger than what we can see? What if the very ground beneath our cosmic feet is tilted? The KBC Void is not just emptiness, it is a riddle written across billions of light years. And it is a riddle that scientists now believe could hold the key to one of the greatest mysteries in modern cosmology. The question of why the universe is expanding faster than expected. But before we can understand that, we must return to the very beginning, to the story of how the universe began, and the principle that guided scientists for nearly a century. The belief that space, in its vastness, is the same everywhere. Among all the details about the KBC Void, one truth stands out like a whisper in the silence. Our own Milky Way galaxy lies close to its center. Of all places in this endless cosmos, we happen to live in the middle of a vast hollow. Think of it like this. Imagine standing in the center of a great cavern. Around you, the walls fade into darkness. The air carries a strange stillness, and your small lantern flickers against emptiness. You cannot see the boundaries, You cannot measure how deep the hollow goes. All you know is that you are suspended within it. That is our place in the universe. Our galaxy, with its spiral arms and billions of stars, drifts like a fragile lantern inside this immense cosmic chamber. The knowledge is at once humbling and unsettling. For scientists, this fact is more than a curiosity, it is a complication. According to the rules of physics, the universe should not give us such a privileged position. The cosmological principle tells us that we should not occupy a special place, that the cosmos is uniform, and that no corner is unique. Yet here we are, seemingly resting at the heart of a great emptiness. What does this mean? Could it be coincidence, a quirk of where life happened to emerge? Or could it hint at something deeper, that our corner of the universe is different from others in ways we do not yet understand? If the void truly defines our environment, then our measurements of the universe might be shaped by it. The speed at which galaxies seem to move apart, the way light stretches as it travels to us, even our estimates of cosmic expansion, all could be influenced by this hollow we call home. And beyond that lies an even more haunting question. If we live in a special isolated region, what lies beyond its edges? Do the rules change once we step outside? Does matter grow denser? Does gravity act differently? Could the very fabric of space and time shift once we pass beyond the boundary? For now, these questions remain open. Like doorways in the dark, we peer outward, but the distances are too immense, the light too faint. The void hides its answers behind a curtain of time. And so, we stand in the center, aware that we are both surrounded and alone. Our galaxy, our sun, our Earth, all of it rests inside a bubble of scarcity, a hollow, unlike most others. It is as if the cosmos itself placed us here to wonder at the strangeness of existence. From this position, questions echo louder. If our vantage point is unusual, what does that say about the laws of the universe? Are they as universal as we believe, or are they more fragile, more local than we dare to admit? If our galaxy rests near the center of this vast hollow, then a question rises as naturally as breath. What lies beyond it? Close your eyes and imagine the boundary of this void, not a wall, not a barrier, but a soft horizon where emptiness gives way to fullness again. Out there, galaxies begin to cluster more tightly. Stars crowd together in greater numbers. The silence gives way to a cosmic symphony. But could it be more than that? Could the very rules of reality shift when we cross this unseen threshold? Scientists wonder whether the space outside this void is different, not only in density, but in essence. Perhaps gravity behaves differently there, tugging more strongly. Perhaps time itself flows in subtle, unfamiliar ways. Perhaps the structures that shape galaxies take on new forms. In this way, the void becomes not just a hollow, but a frontier. For centuries, humanity has gazed at horizons and asked the same question: what is on the other side? Sailors looked across oceans, explorers across deserts, astronomers across the sky. Each time, the answer reshaped our world. And now, the greatest horizon of all surrounds us, the horizon of the void. Yet there is beauty in not knowing. The mystery invites us to dream, to imagine possibilities beyond the edge of our comprehension. Could other regions of the universe, beyond this hollow, be richer, denser, more vibrant? Or could they be stranger still, shaped by laws we have yet to discover? And so, the void is not simply an absence. It is a mirror, reflecting our own curiosity back at us. By asking what lies beyond it, we are really asking how much of the universe we truly understand. We are asking whether the rules we use to describe the stars are eternal truths, or fragile local patterns, as temporary as ripples on water. The answers remain hidden in the distances. Light from those faraway regions has yet to reach us. It will take millions, even billions of years before it does. Until then, we live in the quiet heart of this cosmic chamber, wrapped in questions that may outlast us. But perhaps that is what makes this mystery so soothing. The universe is vast enough to hold questions that no single lifetime can answer. And still, we are here, small but awake, daring to wonder. Every mystery has a beginning. And the story of the KBC Void began not with poets or dreamers, but with scientists quietly studying the night sky. In 2013, 3 astronomers, Ryan Keenan, Amy Barger, and Lennox Cowie, were examining the distribution of galaxies around us. Their work was not meant to uncover a cosmic secret. It was simply careful observation, the kind that science thrives on. And yet, in those patterns, they noticed something startling. Instead of a smooth spread of galaxies, as theory predicted, there was a vast thinning, a hollow unlike any they had seen before. When they ran the numbers again, the emptiness remained. When they compared it against known principles, the void refused to disappear. What they had stumbled upon would come to be called the KBC Void, bearing their initials. But at the time, it was less a discovery than a shock. For decades, astronomers had trusted the cosmological principle, the idea that, on the largest scales, the universe should look roughly the same everywhere. Galaxies might cluster here or scatter there, but in the end, the balance would hold. The fabric of space would remain uniform. The KBC Void tore a hole in that certainty. This was not just a thinner patch of sky, like a clearing in a forest. It was an emptiness so large that it violated the very assumptions scientists use to describe reality. When Keenan, Barger, and Cowie presented their results, the scientific community was shaken. Could it be true that we live inside one of the largest known voids in the observable universe? If so, what did that mean for all of cosmology? If the universe is not uniform, then the equations we trust might need rewriting. Some resisted. Surely this was a mistake in measurement, a flaw in the data, a mirage created by incomplete surveys. But as years passed, more studies hinted that the void was real. The silence in that part of the cosmos was too consistent to ignore. This is the nature of science. Sometimes, the most profound discoveries arrive not with trumpets and fireworks, but with a quiet anomaly, a small discrepancy that refuses to vanish. And when we pull at that thread, the tapestry of the universe begins to reveal patterns we never imagined. The KBC Void was one such thread. A quiet paper, a few names, and yet an idea powerful enough to unsettle the foundations of our understanding. For the scientists who first described it, the void was both a challenge and an invitation to question what we thought we knew and to look deeper into the mysteries of space. And so, from 3 patient astronomers studying the stars, the world was given a riddle that still echoes today. To understand why the KBC Void is so unsettling, we must travel far, far back, beyond galaxies, beyond stars, to the very birth of everything. About 13.8 billion years ago, the universe began with what we call the Big Bang. Do not imagine an explosion in the ordinary sense. Instead, picture the sudden swelling of space itself, everywhere, all at once. Energy and light rushing outward, expanding like ripples in a pond after a pebble drops. From that first instant, the cosmos unfolded with astonishing speed, stretching in every direction. In those early moments, energy spread evenly, like cream dissolving into coffee. Matter, too, was believed to have been laid down with the same balance. This idea that on the grandest scales the universe should look the same everywhere came to be called the cosmological principle. It was a comforting thought. If the universe is uniform, then the laws we uncover here on Earth should hold true everywhere. On the far side of the galaxy, in the depths of a nebula, even at the edge of the observable universe, gravity should pull the same. Light should bend the same. Stars should form under the same rules. The cosmos, though vast, would still be familiar. For decades, this principle was the bedrock of cosmology. It meant we could study the stars above our heads and trust that their behavior echoed throughout the universe. It allowed scientists to weave a coherent story, from the Big Bang to the galaxies we see today. But then came the evidence that the universe was not perfectly smooth. When astronomers mapped the sky, they found regions where galaxies crowded close together and other regions where they were scarce. Cosmic web-like patterns emerged, filaments of light stretching across darkness, knots of matter woven together, and between them, vast hollows. This unevenness was not entirely surprising. Over time, gravity naturally pulls matter into clusters. But the KBC Void was different. Its immensity went beyond expectation. It was as if the universe had not simply rippled, but had left behind a canyon of near-nothingness, too deep, too wide, to fit the neat picture of uniformity. And here lies the contradiction. If the Big Bang spread matter evenly, why does such a vast hollow exist? If the cosmological principle is correct, how can we find ourselves at the heart of such an exception? It is like standing in a forest where the trees were meant to be evenly spaced, only to discover a massive clearing miles across where no trees grow at all. One clearing might be dismissed as chance, but when the clearing is larger than the forest itself was ever expected to allow, questions must be asked. The KBC Void forces us to reconsider whether the universe is truly uniform, or whether our place within it is more peculiar than we imagined. And if our cosmic neighborhood is indeed unusual, then our measurements of the universe, its expansion, its age, even its destiny, may be colored by the emptiness that surrounds us. To seek answers, scientists look deeper still, not only at galaxies today, but at the faint afterglow left from the Big Bang itself. For hidden in that ancient light lies the blueprint of the universe, and perhaps the first hints of why such a void exists. For nearly a century, the cosmological principle comforted scientists. It told us that on the grandest scales, the universe was balanced, even fair. That wherever you looked, whether nearby or unimaginably far, the stars would follow the same rules. But as telescopes grew stronger and surveys mapped wider swaths of the sky, a more complicated picture began to emerge. Astronomers saw not uniformity, but structure. Galaxies did not scatter evenly like grains of sand. Instead, they gathered in clusters, like families huddled together. Those clusters connected into filaments, weaving vast chains of light that spanned across the darkness. Between them stretched hollows, great empty regions, darker than expected. It was as though the universe had formed a cosmic web, glowing threads of galaxies separated by gaping voids. To the human eye, the pattern was beautiful, like frost spreading across glass, or veins running through a leaf. But scientifically, it raised unsettling questions. If matter was supposed to spread evenly after the Big Bang, how did such extremes arise? Some unevenness could be explained. Tiny fluctuations in the infant universe. Slight differences in density grew over billions of years. Gravity tugged on these differences, pulling galaxies closer in some regions, leaving others bare. This explained small voids, modest gaps in the web. But the KBC Void stood apart. Its sheer size defied these gentle explanations. It was not a ripple but a chasm, so large that it bent the very rules it was supposed to follow. It wasn't simply a matter of galaxies being thinner here. It was a structural anomaly, an enormous imbalance written into the cosmos itself. This revelation shook the belief in universal sameness. If one part of the universe could be so different, what about others? Could the laws of physics themselves vary across vast distances? Could gravity behave slightly differently outside our hollow? Could time itself flow in a rhythm that is not mirrored elsewhere? For centuries, we believed the night sky was a mirror, reflecting the same truths no matter where you gazed. But with the discovery of this void, the mirror cracked. We could no longer be certain that the truths we measure here apply everywhere. And yet, there is wonder in this uncertainty. To live in such a peculiar region is to be given a mystery large enough to cradle generations of questions. It means that the universe is not flat and predictable, but alive with complexity structured in ways we are only beginning to glimpse. The KBC Void is not just an emptiness. It is a challenge, a silent reminder that the cosmos may still hold surprises that force us to rewrite what we thought we knew. Voids in the universe are not new to science. Astronomers have mapped many of them pockets of space where galaxies are fewer, where the cosmic web thins. Most are expected, natural outcomes of gravity, tugging matter into clusters and leaving behind sparse clearings. But the KBC Void is different. It is not a small hollow, a gap between filaments. It is vast beyond comparison, stretching up to 1 billion light-years across. Its size alone makes it extraordinary, but its uniqueness lies in something more, the way it disrupts our expectations. In the grand design of the cosmos, variety is common, but extremes are rare. Just as a forest may have clearings, none are expected to span entire continents. And yet here is a clearing so immense, so empty, that it feels as though a piece of the universe has been carved away. The KBC Void is spherical in shape, like a great invisible bubble surrounding us. This geometry, too, makes it unusual. Most cosmic structures, clusters, filaments, walls are irregular, jagged, tangled. But this void has the quiet symmetry of a sphere, as though the universe pressed pause and left a hollow of silence around our galaxy. Its presence challenges the principle of uniformity. If such a vast bubble exists here, could others exist elsewhere? Or is our place truly special? An unlikely accident that places us at the heart of something rare. Scientists struggle with this, for if the void is as large as some estimates suggest, then it is not just an interesting feature, it is a violation of the rules. It hints that the cosmos may not be governed by the same balance everywhere, that the foundation of modern cosmology may need rethinking. But beyond the science, there is also a quiet poetry in this discovery. We live in a universe where silence and absence can be just as powerful as light and presence, where the spaces between galaxies are not blank margins, but active, mysterious characters in the story of creation. The KBC Void is not just another gap in the web. It is a question made real, a cosmic pause written into the music of the universe. It stands out because it forces us to look again not only at the stars that shine, but at the darkness that surrounds them. When astronomers describe the KBC Void, they do not speak of a jagged or chaotic structure. Instead, they describe something almost serene. A sphere, a vast, nearly spherical region of space, smooth in its enormity, hollow in its silence. To imagine its size, let us place it beside other cosmic structures. The Laniakea supercluster, our galactic home, spans roughly 500 million light-years and contains about 100,000 galaxies, including our own Milky Way. Immense, yes, but the KBC Void could stretch twice as far, extending up to 1 billion light-years in radius. It is 4 times larger than the Laniakea supercluster. In terms of scale, this void may account for as much as 2% of the entire observable universe. A single hollow, occupying a measurable fraction of all that we can see. It is as though a painter brushed a vast circle of emptiness across the canvas of the cosmos, leaving stars and galaxies only at its edges. And yet, describing it as empty is not quite right. Within this sphere, galaxies still exist, fewer, scattered, thinner than elsewhere, but present nonetheless. They are like faint lanterns flickering inside a cavern, not extinguished, only rare. What makes the void haunting is not its total absence, but its contrast. Outside its borders, galaxies gather more thickly, woven into filaments and walls. Inside, the thinning is clear, deliberate, unmistakable. It is a cosmic bubble, suspended in the web of creation. This symmetry, this smoothness, raises questions of its own. Why should such a void form at all? And why should it form so evenly, so cleanly, as if the universe itself had drawn a circle and pressed the galaxies outward? Perhaps most remarkable of all is our position. To be near the center of this sphere is to be uniquely placed for observation. Imagine living inside a soap bubble, your world surrounded by delicate film. No matter where you look, the bubble's edges curve away at the same distance, cradling you in the middle. That is our reality. We gaze outward, and though we see countless galaxies, their numbers are subtly diminished in every direction. It is almost as if the void itself has chosen us as its observers, placing us at its quiet heart, whispering to us of mysteries still hidden beyond. When we hear the word void, we often imagine pure nothingness, a black canvas without a single star, a silence so complete it feels absolute. But the KBC Void, for all its immensity, is not truly empty. Galaxies still exist here, scattered thinly across the darkness like faint fireflies in a wide meadow. Stars still burn, though more distantly spaced. Matter still flows, but less generously. Compared to the crowded regions beyond its edge, the void feels hollow, like a whisper of a song instead of its full chorus. Astronomers estimate that inside this void, the density of matter, stars, galaxies, clusters, is about 20% lower than the cosmic average. To us, 20% might not sound overwhelming. It is the difference between a glass filled to the brim and one sipped down slightly. But on cosmic scales, that difference is extraordinary. It is the subtle shift that changes the shape of the universe itself. Think of it like the air in a room. Remove just a fraction of the oxygen, and suddenly breathing becomes difficult. The change is small, yet life itself is altered. In the same way, a 20% thinning of matter across 1 billion light-years is enough to unsettle the balance of the cosmos, tugging on galaxies, warping measurements, and perhaps even influencing how we perceive the expansion of the universe. This is why the KBC Void matters. Not because it is barren, but because it is less than expected, less than theory predicted, less than the smooth, even universe the cosmological principle once promised us. And it is precisely in this less that mystery resides. Why should the universe carve out such a hollow? Why should stars be fewer here, as though some great hand had swept them aside? To live inside such a place is to be surrounded not by absence, but by scarcity. It is like standing in a forest where the trees are spaced wide apart. The silence is thicker, the shadows deeper. Every light seems more precious for the darkness around it. And so, while the KBC Void is not a total emptiness, it is a space defined by its rarity. It is a reminder that the universe is not evenly woven, but full of contrasts, crowded and sparse, bright and dim, full and hollow. At first glance, the KBC Void may appear to be only an oddity, an empty bubble in the tapestry of space, but science rarely stops at appearances. Beneath the silence of this hollow may lie a clue to one of the most puzzling mysteries of our time. Since the Big Bang, the cosmos has been stretching outward. Galaxies drifting apart like petals carried on the surface of an inflating balloon. For decades, scientists have tried to measure the exact rate of this expansion, known as the Hubble constant. And here, the story becomes tangled. Two main methods exist for measuring this constant. The first looks close to home, at nearby galaxies and brilliant exploding stars called supernovae. These cosmic beacons allow astronomers to gauge distances and speeds with remarkable accuracy. According to these local observations, galaxies are racing apart faster than expected. The second method looks much farther back. It studies the faint afterglow of the Big Bang itself, the cosmic microwave background. Ancient light that has traveled for 13.6 billion years to reach us. From this light, scientists reconstruct a picture of the young universe, and from that picture, calculate how fast expansion should be happening today. This method gives a slower rate, and so, we are faced with a tension. Nearby galaxies whisper that the universe expands quickly. Ancient light insists it should be slower. This disagreement is called the Hubble tension, and it is one of the great unsolved puzzles of modern cosmology. Here is where the void may matter. If we truly live inside the KBC Void, then the galaxies we observe around us are not representative of the cosmos as a whole. They are influenced by the gravitational imbalance of our hollow. The regions of space outside the void, denser and heavier, may be tugging on the galaxies inside, pulling them outward more forcefully, making them appear to race away faster than the universal average. In this way, our cosmic environment could be tricking us. We measure the expansion of the universe from inside a hollow, and so our numbers are skewed. The KBC Void may not only explain why galaxies seem to flee more quickly than theory allows, it may also help bridge the gap between the two clashing methods of measurement. It is humbling to think that the answer to such a grand mystery might lie not in the farthest reaches of space, but in the quiet hollow we call home. That our very position, this lonely lantern at the center of a vast bubble, might color the way we see the cosmos. The void, in its silence, may hold the first notes of an answer. To understand the mystery of expansion, imagine trying to measure the heartbeat of the universe itself. Scientists call this rhythm the Hubble constant, a number that tells us how quickly galaxies drift apart, how swiftly the fabric of space stretches. The first way to measure it is to look nearby, at galaxies we can see with clarity, and at some of the most dramatic events in the cosmos. Supernovae. These exploding stars shine so brightly that they can outshine entire galaxies for a brief time. Because their brightness follows predictable rules, they act as standard candles, reliable markers that allow astronomers to measure vast distances with surprising precision. By comparing how bright a supernova appears to us with how bright we know it truly is, scientists calculate its distance. Then, by observing how quickly its galaxy is moving away measured through the redshift of its light, they can piece together the speed of expansion in our local cosmic neighborhood. When they do this, the numbers are startling. The galaxies nearby seem to be receding at about 45 kilometers per second per megaparsec. That means, for every 26 million light-years, 1 megaparsec galaxies move away from each other. 45 kilometers faster every second. It is as if space itself is stretching under their feet, carrying them outward on a current that never rests. To put this into perspective, picture dots drawn on the surface of a balloon. As the balloon inflates, the dots drift apart. The farther apart they are, the faster they separate. This is the image of our universe, an endless balloon, expanding quietly in all directions. And yet, this local method of measurement tells us a story of urgency. A universe that expands faster than expected, galaxies rushing away more quickly than ancient models predict. It is as though the heartbeat we hear nearby is quicker, more hurried, than the one we expected from the past. But science is cautious. Before declaring the mystery solved, astronomers turn to another method. A deeper, older voice, echoing from the dawn of time itself. And what it whispers is slower, calmer, more deliberate. If the first method listens to the present heartbeat of the cosmos, the second listens to its childhood. To do this, astronomers turn not to nearby galaxies, but to the oldest light in existence, the cosmic microwave background. This faint glow, invisible to our eyes but detectable with sensitive instruments, has been traveling for nearly 13.6 billion years. It is the afterglow of the Big Bang itself, a whisper left behind when the young universe cooled enough for light to roam free. To study it is to open an ancient diary, written when the cosmos was still in its infancy. By carefully analyzing this glow, scientists reconstruct the conditions of the universe shortly after it began. Its density, its ingredients, its geometry. From these early patterns, they can calculate how the universe should have expanded over billions of years, and therefore how quickly it should be stretching today. And here lies the surprise. The cosmic microwave background suggests a slower expansion rate, about 41 kilometers per second per megaparsec, a quieter rhythm, more deliberate than the one measured with local galaxies. It is as if the universe we see now is tapping its foot faster than the music written in its earliest score. The nearby stars tell us one tempo, while the ancient light tells us another. This discrepancy is what scientists call the Hubble tension. At first, many thought the difference was a mistake, an error in measurement, a flaw in the instruments, a smudge on the cosmic lens. But as the data improved, the discrepancy remained, solid and undeniable. Two methods, both precise, both reliable, yet leading to two answers that refuse to align. It is here that the KBC Void re-enters the story. If we live in a hollow where galaxies are fewer, the tug of gravity may not be the same as elsewhere. The denser regions outside may be pulling on us, stretching galaxies within the void just a little faster, creating the illusion of a higher local expansion rate. In this way, our strange position in the universe could be distorting our perception, like a child blowing a bubble from inside, seeing the world expand differently than someone watching from outside. The question is no longer whether the void exists. It is how much influence it truly holds. Now the puzzle sharpens. On one side, nearby galaxies and brilliant supernovae tell us the universe is expanding quickly, about 45 kilometers per second per megaparsec. On the other side, the ancient light of the cosmic microwave background whispers a slower rhythm, about 41 kilometers per second per megaparsec. Two methods, both precise, two truths, both convincing. Yet they do not agree. This disagreement is more than a quirk of numbers. It is a crack in the foundation of cosmology, a reminder that even our most trusted measurements can diverge. Scientists call it the Hubble tension, and it lingers like a question that will not let go. Imagine listening to two clocks in a quiet room. Both tick steadily, both crafted with care. But one ticks just a little faster than the other. At first, you think your ears deceive you, but as the minutes pass, the difference grows impossible to ignore. That is what scientists feel when comparing these two cosmic rhythms. If the microwave background is correct, the present-day universe should be calmer, slower. If the local galaxies are correct, then the cosmos is in more of a rush, expanding with unexpected haste. The gap between these answers is small in numbers, only about 8%, but in cosmology, even a whisper becomes thunder. Some suggest the tension hints at new physics, forces or particles not yet discovered. Others suspect subtle flaws in measurement. And still, others look to our environment, the KBC Void, for an explanation. Perhaps our hollow distorts what we see, pulling galaxies outward, making the expansion appear faster from where we stand. But if that is true, then our cosmic position is not ordinary. We are not random observers in a uniform universe. We are lanterns flickering in the middle of a hollow, measuring the universe through the lens of our peculiar home. The Hubble tension remains unresolved, a mystery suspended between the past and the present, and as long as it persists, it whispers that the cosmos still holds secrets, waiting to be uncovered. To seek an answer to the Hubble tension, scientists turn to a familiar force, gravity. The same invisible pull that keeps our feet on the ground, that binds the moon to the earth and the earth to the sun, may also be shaping the motion of entire galaxies across cosmic scales. Think for a moment of how gravity works in daily life. A mountain has more mass than a hill, so it tugs a little stronger. A star has more mass than a planet, so it pulls with greater force. Now imagine this principle stretched across millions of light years. Regions of space dense with galaxies exert greater gravitational pull, while the void's thinner, lighter pull less. If we live inside a void, then we are like passengers drifting in a lighter current. Beyond the edges of our hollow, denser regions tug outward on galaxies inside, pulling them toward the walls of the cosmic bubble. This extra tug adds to the natural expansion of space itself, giving the illusion that galaxies around us are rushing away faster than they should. It is as if the universe is playing a game of balance. The void releases, the dense regions grasp. From our vantage point in the hollow, we see galaxies accelerate, carried by both the stretch of space and the gravitational draw from beyond. This idea does more than offer comfort. It provides a possible bridge between the two conflicting measurements of expansion. The microwave background reflects the universe as a whole, averaged across countless regions. Our local observations, however, are colored by the peculiar gravity of our hollow. Two perspectives, two truths, both correct within their own frames. And yet, even this elegant explanation raises questions. How strong is this gravitational imbalance? How far does its influence reach? Does it explain only our local corner of the cosmos? Or does it ripple outward into the grand fabric of the universe? The answers remain uncertain, but the beauty of science lies in this very uncertainty. Each hypothesis is not a final word, but a lantern carried into the dark. And with each lantern, the outlines of the unknown grow clearer. For now, gravity offers us a story, that we live in a hollow, gently tugged by the denser realms beyond, and that this silent tug may be shaping the way we see the universe itself. The void hypothesis has stirred both excitement and caution among scientists. For some, it feels like a missing piece of the puzzle. For others, it is only one possibility in a sea of uncertainties. Brian Keating, a cosmologist at the University of California, San Diego, considers the idea plausible. In his view, the KBC Void could indeed explain why galaxies near us seem to drift apart faster than the cosmic average. If dense regions outside the void are tugging at galaxies within, then our measurements are naturally distorted. From inside the bubble, the universe appears to race. From outside, the story may be calmer. Yet Keating and others are careful not to claim victory too quickly. The model depends on assumptions about the size of the void, its symmetry, and the way gravity acts across such colossal distances. Different models predict different outcomes. Some suggest the void could fully explain the Hubble tension. Others show its influence is too weak. Indranil Banik, a researcher at the University of St. Andrews, has worked extensively on the void's possible effects. His calculations suggest that matter inside the void is indeed thinner, by about 20% compared to the regions beyond. A subtle difference, yet across a billion light-years, it may matter greatly. Still, even Banik admits the picture is incomplete. The void may help, but it does not erase the mystery entirely. This is how science grows. Not with sudden, perfect answers, but with layers of questions and cautious steps forward. Some researchers believe the void is a clue. Others argue it is a distraction, pointing instead to undiscovered physics, new particles, new forces, new dimensions. What unites them all is the acknowledgement that something is missing. The numbers do not align, and the universe refuses to be simple. For us, this uncertainty is not a frustration, but an invitation. It reminds us that even in an age of satellites and supercomputers, the cosmos still holds riddles deep enough to humble us. We are explorers not only of space, but of questions themselves. When the KBC Void was first proposed, its estimated size was staggering up to 1 billion light-years in radius. A hollow so vast, it seemed to account for nearly 2% of the observable universe. But as with many cosmic discoveries, the closer scientists looked, the less certain those first numbers became. Later studies suggested something smaller. By using more precise surveys of galaxies and improved ways of measuring their distances, astronomers recalculated the boundaries of the void. One group, examining the motions of thousands of galaxies, proposed that the void might be closer to 230 million light-years, across almost 10 times smaller than early estimates. On human scales, such a size is still unimaginable. Yet in cosmic terms, a billion light-year hollow could dramatically influence how we perceive cosmic expansion. A 230 million light-year hollow, its effect would be far weaker, too small to fully account for the Hubble tension. And so the debate continues. Is the void truly as immense as the early data implied? Or have we overestimated its reach, mistaking local variations for something grander? Part of the difficulty lies in perspective. We live inside the void, peering outward from its center. It is like trying to measure the walls of a vast cave with only a lantern in hand. Light travels across billions of years, galaxies shift and drift, and the instruments we use, though powerful, are still bound by the limits of what we can see. This uncertainty is humbling. The void exists that most agree on, but how large it truly is, and how deeply it affects our measurements, remains unresolved. It may be a colossal anomaly reshaping our view of the cosmos, or it may be only one small irregularity among many. An echo of deeper mysteries still hidden from sight. Science moves gently forward, narrowing possibilities, refining numbers, testing theories. Each step brings us closer, but the horizon keeps receding, reminding us that the universe is vast enough to keep its secrets a little longer. For a time, the KBC Void seemed like a singular anomaly, an extraordinary hollow that made our place in the cosmos feel strangely unique. But as astronomers expanded their surveys, mapping the sky in greater detail, another possibility emerged. Perhaps our void is not alone. The DESI project, one of the most ambitious efforts to chart the universe, has revealed something remarkable. Across the cosmic web, voids appear again and again, scattered like bubbles between filaments of galaxies. Some are modest, spanning only a few dozen million light-years. Others stretch wider, rivaling the KBC Void itself. If voids are common, then our position within one is not as unusual as once thought. The universe may be full of these hollow regions where galaxies are sparse, balanced by regions where they cluster more densely. Like foam floating on water, the cosmos forms a pattern of bubbles and walls, light and darkness interwoven. This perspective softens the sense of isolation. We are not the only lantern glowing in a hollow. Across the universe, countless other galaxies shine in their own voids, separated by gulfs of silence but part of the same grand structure. Still, the KBC Void retains its intrigue. It is among the largest we know, and its central placement around our galaxy gives it special importance for how we measure the cosmos. Even if voids are common, this void shapes our observations in ways others do not. Perhaps this is the greater lesson, that the universe is not uniform, but textured. Not smooth, but patterned. It is a tapestry of contrasts, dense filaments and empty hollows, brilliant clusters and silent gaps. And in that contrast, just as music needs both notes and rests, the cosmos is made of both presence and absence. To know that voids are common does not make our own less meaningful. It reminds us that emptiness, too, has a place in the design of the universe. It is one thing to know that we live inside a void. It is another to imagine what it would mean to leave it. For now, the thought is only a dream. The distances are far too great, the technology far beyond us. Even the nearest edges of the KBC Void lie hundreds of millions of light-years away, an expanse so vast that no ship, no telescope, no signal could ever cross it in a human lifetime. And yet, imagination is not bound by engines or fuel. It allows us to wander freely, to ask questions without fear of distance. So let us dream. What if humanity had the means to travel? What if we possessed ships capable of gliding through space for eons, their passengers shielded from radiation, their engines able to accelerate without end? What would it mean to approach the boundary of the void and to see what lies beyond? Perhaps the first thing we would notice is change. Galaxies, once sparse and faint, would begin to cluster more tightly. The emptiness would give way to richness. The cosmic silence would grow busier, filled with the glow of stars gathered in greater numbers. Outside the void, the universe would not feel the same. And then, deeper questions arise. If the density is different, what else changes? Would the very laws of physics shift as we cross this invisible border? Would gravity behave with greater strength, binding galaxies more firmly? Would time itself seem to flow differently, measured against the pulse of denser regions? We cannot yet know. But the question itself has value. To wonder about what lies beyond the void is to stretch the boundaries of human thought. It is to admit that our perspective is limited, that the cosmos might surprise us in ways we have not yet imagined. Like explorers gazing across an uncharted ocean, we may never set sail, but the act of standing at the shore and asking what lies beyond is enough to remind us of the infinite. It is tempting to imagine a great leap, the kind we see in stories where a ship blazes into the stars at impossible speeds, carrying explorers across the galaxy in a single burst. But nature does not bend so easily. The human body, delicate as it is, carries limits that the cosmos will not forgive. When a rocket launches from Earth, we already feel the weight of acceleration pressing down, a force called G. At just 4 to 6 times Earth's gravity, blood struggles to reach the brain. Vision dims, consciousness flickers. For a few moments, the body can endure. But if the force lingers, life itself falters. Now, imagine trying to leap instantly to the speed of light, as films often portray. The acceleration would not be 4 or 6 Gs, it would be thousands. Bones would shatter, organs would fail, the body would be crushed into silence. No shield, no suit, no technology we know could protect us from such a violent surge. Even ships themselves suffer from this reality. Every material has limits, every structure a breaking point. To accelerate too quickly is to invite destruction, to burn out before the journey even begins. This is why real exploration cannot be a sudden leap. It must be gradual, patient, measured, an acceleration so gentle that the body hardly notices, stretching over days, weeks, months, like drifting on a river rather than falling from a cliff. Here lies the quiet paradox. The stars invite us to hurry, to cross the voids in great strides. Yet our nature insists on slowness. We are fragile passengers, designed for the soft gravity of Earth, carrying hearts that beat to a rhythm measured in breaths, not in light years. And so, for we can dream of ships that pierce the darkness. To explore not only demands courage and technology, but also humility, the acceptance that our flesh is as delicate as a candle flame, and the universe is vast beyond measure. If we cannot leap suddenly to impossible speeds, then perhaps the answer lies in patience. Imagine a ship that accelerates gently, almost imperceptibly, just 1 meter per second, every minute. To us, that feels like nothing at all. A soft push you might barely notice. But in the quiet arithmetic of time, small steps add up to something extraordinary. In the first minute, the ship moves at 1 meter per second. After 10 minutes, 10 meters per second. After an hour, 60. The increase is steady, calm, almost meditative. And yet, this gentle climb soon surpasses anything humanity has ever built. Voyager 1 took 35 years to reach the edge of the solar system. A ship, accelerating slowly, with patience and persistence, could make the same journey in less than 2 weeks. 2 weeks to step beyond the sun's breath, past the reach of solar winds, into true interstellar space. By the time the ship crossed that threshold, it would already be traveling at over 19,000 kilometers per second, roughly 10% the speed of light. In human terms, unimaginable. On cosmic terms, still a crawl, but a crawl that finally begins to measure against the distances before us. At this pace, stars would no longer be unreachable dreams. They would still demand lifetimes, but lifetimes shortened by magnitudes. Time itself, bent by relativity, would begin to stretch differently aboard the ship, granting passengers a slower clock than the universe outside. This is the way the cosmos teaches us. Not through leaps, but through patience. Gentle, steady acceleration becomes the key to unlocking speed, like walking 1 step at a time, never stopping, until the mountain itself lies behind you. The journey would still be vast. Centuries, millennia, even millions of years would pass before the edge of the void came into view. But in those numbers lies not despair, but wonder, because every step forward, however small, would carry us deeper into the mystery. Every moment of gentle acceleration would be another heartbeat on the way to the stars. In this way, humanity's path to the cosmos may not be sudden conquest, but a slow unfolding, like a flower opening to the sun, one petal at a time. As our ship drifts faster and faster, something subtle begins to stir. It is not a change in the hum of the engines, nor in the flicker of the stars outside. It is a change in time itself. Einstein's theory of relativity tells us that as we approach the speed of light, the flow of time begins to shift. For the traveler inside the ship, the clocks tick normally. A second feels like a second. A heartbeat feels like a heartbeat. But compared to those who remain behind on Earth, watching the stars from home, time begins to stretch differently. At half the speed of light, the difference is already noticeable. Every 10 hours that pass on Earth feel like only 8.5 hours aboard the ship. A small difference at first, but one that grows with each increase in speed. It is as if the universe is offering the traveler a strange gift, a slower passage of time, a lengthening of moments. Imagine sending a message back home during such a journey. For those on Earth, the wait between replies grows longer and longer. Hours, then days, then months. Communication stretches like elastic until dialogue becomes impossible. What was once a conversation turns into silence, bridged only by echoes that arrive too late. For the traveler, though, time feels steady, ordinary. They sip water, read, sleep, and wake again. Life continues, but the world outside begins to race ahead. Civilizations may rise and fall, while the traveler feels only a few years pass. This bending of time is not fantasy. It is written into the very fabric of the universe. It means that a journey to the stars is not just a journey through distance, but through time itself. To leave Earth at near-light speed is also to step away from its history, from its future, from its people. And yet, there is something beautiful in this strangeness. Time dilation reminds us that the universe is not rigid, but fluid. That time, the very medium of our lives, can ripple and bend like light across water. In the quiet cabin of the ship, a traveler gazes at the stars. To them, the moments are ordinary. To the cosmos, they are extraordinary. For with every increase in speed, the traveler drifts not only farther into space, but deeper into time's mysterious embrace. With every patient moment of acceleration, the ship glides closer to the cosmic speed limit. 90% of the speed of light, 95, 99. At these staggering velocities, the world outside becomes a blur, and time itself begins to stretch like a ribbon in the wind. At 90% the speed of light, hours on Earth shrink into minutes aboard the ship. For every hour that passes in the universe beyond, the traveler experiences only about 26 minutes. Time, that steady companion of our lives, no longer beats in unison. It divides, sings in different keys, offering the voyager a private rhythm unknown to those left behind. And as the speed edges closer, 99.99% the speed of light, this difference becomes astonishing. Time on the ship slows to a crawl compared to Earth. Days in the cabin pass while centuries slip away outside. For the traveler, the journey may feel like weeks, months, perhaps a few years. For the universe, entire epochs unfold. Civilizations might rise, fall, and vanish while the voyager still gazes out the window, watching starlight bend into strange arcs. Even space itself begins to warp. The stars ahead seem to crowd together, their light squeezed into bluer hues. Behind the ship, the stars redden and fade, stretched thin by the distance. The universe folds around the traveler's motion, reshaping itself into something unfamiliar, almost dreamlike. This is the poetry of relativity. To move at such speeds is to live in two realities at once. One, slow, intimate, ordinary. The other, fast, sweeping, unfathomable. A paradox carried in every heartbeat. And yet, there is a limit. No matter how long we accelerate, no matter how much energy we pour into our engines, the speed of light remains just out of reach. It is not a barrier we can break, but a wall woven into the fabric of space and time itself. Still, to approach this wall is to touch wonder. It reminds us that the universe is not static, not simple. It is flexible, mysterious, capable of bending even the flow of time. And for the traveler, traveling ever faster, it means the journey is no longer just through space, it is through the very essence of reality. Every road has an end, and every journey meets a boundary. For space travelers, that boundary is the speed of light. No matter how much we dream, no matter how hard we push, the cosmos has drawn a line we cannot cross. At first, it seems only a number. 299,792 kilometers per second. But this number is more than measurement. It is law. It is written into the very fabric of reality. Photons, the particles of light, travel at this ultimate speed, because they have no mass. But anything with mass, no matter how small, cannot reach it. The closer we move toward that limit, the more the universe resists. Think of a runner nearing the finish line, only to find the ground stretching endlessly ahead. Each step brings them closer, but the line itself recedes. The finish cannot be crossed. To reach the speed of light would require infinite energy, more power than exists in all the stars combined. This is not an engineering flaw, not a technological gap waiting to be filled. It is a fundamental truth. The speed of light is not a goal, it is a wall. And that wall is absolute. We have seen hints of this resistance in our own experiments. At the Large Hadron Collider, protons are hurled around a ring, nearly at light speed. They reach 0.999999999, 1 times the speed of light, a fraction so close that it defies imagination. And yet, even there, the final sliver remains uncrossable. The energy required to close the gap climbs toward infinity, a mountain too steep to climb. And so, our imagined ship can approach, but never arrive. It can touch the edge, but never pierce it. To try is to wrestle with the very laws that hold the universe together. There is beauty in this wall. It reminds us that limits give shape to existence. Without boundaries, there would be no rhythm, no order, no story. The speed of light is not a barrier to frustrate us, but a reminder that even infinity has rules. For the traveler, this wall is not the end of wonder. To reach 99.99%, the speed of light is already to live in another reality, where time slows to a crawl, where distances shrink, where galaxies slip past like sparks. To be close to the wall is to touch the profound, even if we cannot pass through it. And so, we drift ever nearer, knowing that some doors are meant not to be opened, but to be gazed upon in awe. If nothing with mass can ever reach the speed of light, then what comes closest? The answer arrived one quiet night in 1991, when scientists detected something so extraordinary, so unexpected, that they could only name it with an exclamation: the "oh my God" particle. It was a single proton, born somewhere in the deep universe, hurled across unimaginable distances before striking the Earth's atmosphere. But it did not arrive at an ordinary pace. This tiny traveler was moving at 99 sextillion, 999 quintillion, 999 quadrillion, 999 trillion, 999 billion, 999 million, 999,000, 951%. The speed of light so close that it was indistinguishable from. To grasp its energy, consider this. That lone proton carried the kinetic force of a baseball traveling at 60 miles per hour. A baseball and a subatomic particle, two objects worlds apart in scale. Yet for a brief moment, they were equals in energy. This was not just a curiosity. It was a message from the universe, a demonstration of how nature herself can accelerate matter to extremes we can scarcely imagine. No human machine, not even the Large Hadron Collider, comes close. It was as though the cosmos whispered, "See, this is what is possible, but never more than this." And yet, even the "oh my God" particle could not cross the wall. For all its power, for all its furious speed, it still fell infinitesimally short of the speed of light. That final sliver remained, unbroken, unbreakable. The discovery filled scientists with awe, but also humility. The laws of physics are not arbitrary. They are woven into the fabric of reality. They allow wonders like this particle to exist, but they also forbid what must remain impossible. For us, the "oh my God" particle is both a marvel and a metaphor. It is proof that nature herself plays at the edge of the possible, skating along the wall of light, but never passing through. And it reminds us that even the smallest things, a single proton, can carry stories that shake our understanding of the universe. If a proton can journey at nearly light speed, crossing billions of light years to strike our fragile world, then perhaps our own dreams of traveling to the stars are not folly. They are simply written in a different ink, not in the certainty of engineering, but in the patience of imagination. Now imagine yourself aboard our near-light speed ship, coasting at 99.99% the speed of light. Inside the cabin, everything feels steady. Clocks tick, meals are eaten, sleep drifts into dreams. To you, time flows as it always has. But outside on Earth, centuries slip away with every passing moment. Days aboard your vessel stretch into decades below. Weeks into centuries, the world you left behind continues its march while you drift in your own slowed rhythm. If your journey lasted only 21 days on board, for observers on Earth, nearly 4 years would pass. What feels like a season to you is an entire era for them. Imagine sending a message home. You write, "We are well." By the time the reply returns, generations may already have grown older, and the longer you travel, the wider the gap becomes. A century aboard your ship could see thousands of years flow on Earth. By the time you leave the galaxy, humanity itself might have changed beyond recognition or disappeared entirely. Civilizations might rise and fall, continents shift, languages fade into silence. For you, the journey is steady and continuous. For Earth, it is history racing by. It is a strange kind of solitude. To live outside the rhythm of your home world is to drift not only through space, but through time itself. You become both traveler and witness, carrying with you the memory of a place that will no longer exist as you knew it. And yet, there is beauty in this. Relativity, though humbling, offers a gift. The chance to see the universe in a way no one anchored to Earth ever can. Stars ahead appear closer, their light shifted into new colors. The path through the void shortens. To you, the cosmos seems to lean in, allowing your journey to continue. The paradox remains. For you, time is ordinary. For the universe, you are a ghost, moving through eons while your own clock whispers only days. In this way, the voyage is not just about distance. It is about time itself slipping away. Time lived differently, divided between you and the cosmos, a journey not only through the stars, but through the fabric of existence. At last, after uncountable years in the language of Earth, the ship approaches the edge of the Milky Way. To the traveler inside, only a fraction of that time has passed a long voyage. Yes, but not the eternity it seems outside. For those who remained on Earth, 100,000 years or more have slipped away like sand through an hourglass. Humanity, as you once knew it, has vanished into history. Behind you, the Milky Way recedes. A luminous spiral, a grand city of stars glowing faintly in the darkness. For so long, it was everything. It held the sun, the earth, every story ever told by humankind. Now, from this vantage, it becomes a single shimmering island in an endless archipelago of light. Crossing the galactic border is not dramatic. There are no walls, no sudden shifts. But slowly, the density of stars thins. The familiar crowded glow fades into deeper silence. The comforting presence of our galactic home shrinks into a halo behind you, until even that halo softens to a pearl against the black. Ahead lies intergalactic space, a realm colder, darker, lonelier than anything imagined. Distances here are staggering. Between galaxies stretch gulfs so immense that even light takes millions of years to cross them. In this ocean, stars become rare, like scattered ships adrift in an infinite sea. There is beauty in this solitude. Imagine standing on the deck of a ship at night, watching the last shoreline fade. The silence is vast, the sea endless, yet the stars above whisper their company. So too does intergalactic space carry a quiet majesty. To leave the Milky Way is to step into pure wonder, the realization that even our galaxy, with its hundreds of billions of stars, is only one small ember in a universe too large to hold in thought. The traveler gazes outward, no longer tethered to the galaxy that raised them. They drift in a place where even loneliness has no name, where silence itself becomes the landscape. The Milky Way is behind, the void ahead. And so, the journey continues farther into the dark, toward the edge of the hollow that cradles us. At last, After millions of years aboard the ship, and billions of years as measured by Earth's forgotten clocks, the boundary of the KBC Void draws near. The hollow that once felt endless now reveals its quiet edge, like the faint rim of a vast bubble. For so long, the stars within the void were sparse, flickering like distant lanterns in a near-empty field. But here, at the boundary, change becomes undeniable. Galaxies grow more frequent. They cluster in groups, then in walls, forming luminous chains that stretch across space like cosmic bridges. The silence of the void gives way to a quiet hum, the density of creation swelling around you. Crossing this edge is subtle. There are no gates, no visible line, but the difference is felt in the pattern of light. Outside the void, the universe becomes busier, woven more tightly, as if the threads of the cosmic web pull closer together. It is not just the number of galaxies that increases, but the gravity itself. Stronger, denser, more insistent. Here, the invisible hand that binds the cosmos tugs more firmly. The ship must navigate carefully, adjusting its course to the massive clusters and filaments that shape the flow of space. For the traveler, it is a moment of awe. To look back is to see the vast hollow, faint and ghostly, a memory of emptiness. To look forward is to see abundant galaxies shimmering like jewels, forming superclusters, great walls, structures so immense that even imagination strains to hold them. Here, the void ends. And beyond it, the universe begins to reveal its full richness, its architecture carved by gravity and time. The question arises, soft but profound. If the void shaped our view of the cosmos so deeply, what new truths might unfold as we step into denser realms? What mysteries lie hidden in the places where galaxies crowd together, whispering of forces even stranger than emptiness? The traveler floats at this threshold, poised between two realities, the hollow that cradled us and the fullness that lies ahead. Crossing the boundary of the KBC Void is like stepping from a quiet meadow into a bustling city. The emptiness fades, and suddenly the universe grows alive with light. Galaxies no longer sit in solitude. They cluster, they gather. They weave themselves into patterns so immense they seem almost deliberate. Astronomers call this vast design the cosmic web. It is the skeleton of the universe, stretching across billions of light years. Imagine delicate threads glowing in the dark, each strand a chain of galaxies. At the nodes where strands meet, entire superclusters form, colossal gatherings of matter drawn together by gravity's patient hand. Here, galaxies do not merely exist, they interact. They orbit one another, collide, merge, and give birth to new stars. The space between them is not empty silence, but a theater of constant motion. Some galaxies glow blue, alive with young suns. Others shine red, their stars old and weary. Together, they create a symphony of light and time. From the traveler's perspective, this change is breathtaking. After drifting through the quiet void, where galaxies were scattered like rare lanterns, the sight of such abundance feels overwhelming. It is as though the universe itself has decided to reveal its hidden richness, drawing back a curtain to show the crowded stage beyond. Science tells us that dark matter, the unseen mass that makes up most of the universe, is what shapes this cosmic web. Though invisible, its gravity guides galaxies into filaments and walls, forming the structure that defines the cosmos. It is as if the universe has written itself on an invisible scaffold, a map drawn in the dark. For the traveler, this realization carries weight. To leave the void is not only to encounter more galaxies, it is to glimpse the architecture of the universe itself, the hidden framework that underlies all creation. And so the journey continues, deeper into the web of light, where emptiness gives way to fullness, and the universe reveals the beauty of its design. As the traveler drifts deeper into the crowded web, another truth begins to surface. What we see even here, in this tapestry of galaxies, is still only a fraction of the whole. Astronomers estimate that within the observable universe, there are at least 100 to 200 billion galaxies. Some models suggest the number could reach 2 trillion or more, a richness almost beyond comprehension. Each galaxy, in turn, carries hundreds of billions of stars. And many of those stars may cradle planets of their own. The observable universe itself is a sphere about 93 billion light-years across. That is the distance light has traveled since the Big Bang, stretched by the expansion of space. To give it scale, 1 light-year is nearly 10 trillion kilometers. To cross the observable universe at the speed of light would take longer than the entire history of the cosmos. And yet, even this staggering sphere is not the whole story. It is merely the part we can see, limited by the age of the universe and the speed of light. Beyond its edge lies more, perhaps endlessly more, regions whose light has not yet reached us and may never reach us. Forever hidden by the constant expansion of space. This is the paradox of observation. The farther we look, the older the light we see. To gaze across the cosmos is to peer back in time, catching galaxies not as they are now, but as they were millions or even billions of years ago. The farther the traveler looks, the younger the universe appears. And so, even as the ship moves beyond the void, even as galaxies cluster thickly in the cosmic web, the awareness grows that what is visible is still only a small piece of a far greater whole. Like standing on a mountaintop and seeing endless valleys stretch away, the traveler knows that beyond every horizon lies another, and another, without end. The observable universe is vast beyond measure, yet it may be only a drop in an ocean without shores. Every journey eventually meets a horizon. For sailors, it is the line where sea meets sky. For us, it is the edge of what light has had time to reach since the birth of the universe. Astronomers call this the cosmic horizon, the boundary of the observable universe. It stretches some 46 billion light-years in every direction. Not because the universe is only that large, but because beyond this distance, light has not yet arrived. The cosmos may well extend forever, but our vision stops here, bound by time itself. Looking outward, we realize something humbling. The farther we gaze, the older the universe becomes. Nearby, galaxies shine in their present form. Farther ones show us their youth, when stars were first kindled. At the edge, we glimpse the faint afterglow of the Big Bang. Light that has traveled almost the entire age of the universe. To look out is to look back, as if the universe has folded history into the fabric of the sky. But what lies beyond? That is the haunting question. If the universe is infinite, then past the horizon lie uncountable galaxies, countless stars, endless worlds, echoes of what we see here, repeating without end. Perhaps there are even entire regions where the cosmos is arranged differently, where matter clumps more densely, or laws of physics play by other rules. Some cosmologists whisper an even stranger thought. If the universe is infinite, then every possibility may exist somewhere. Another Earth, another you, living a life only slightly different. A universe not just vast, but endlessly self-reflecting, a mirror without edges. And yet, we cannot see it. The horizon is absolute, drawn not by walls but by time. Beyond it, the universe expands too quickly, pushing galaxies away faster than their light can ever reach us. No telescope, no ship, no dream will let us peer beyond. The cosmic horizon is both a boundary and a promise, a reminder that the universe is larger than our sight, and that mystery itself is part of the design. Even though the cosmic horizon marks the edge of what we can see, its presence does not silence the universe beyond. Sometimes, the unseen tugs on the visible, leaving whispers of its existence in the motions of galaxies. In 2008, astronomers discovered something that deepened the mystery. Galaxy clusters, spread across billions of light-years, as though caught in a vast current. This strange, coordinated drift is called dark flow. It should not be there. According to our models, the large-scale universe should be evenly balanced, with no preferred direction. Yet here were entire swaths of galaxies streaming like leaves on a river, pulled by something we cannot see. What could cause this? One possibility is that colossal structures lie beyond the horizon, too far away for their light to reach us, but close enough for their gravity to stretch across space. Imagine enormous concentrations of mass superclusters, great walls of galaxies tugging at our observable universe from the other side of invisibility. Another possibility is more radical, that the tug comes not from within our universe at all, but from outside. Some scientists suggest that what we see as dark flow could be the gravitational influence of other universes, bubbles of reality beyond our own, pressing against the edges of our cosmic horizon. For now, no one knows for certain. The evidence is debated, the data refined, the interpretations cautious. But whether caused by hidden structures or by something more profound, the fact remains. Galaxies seem to drift in ways that cannot yet be explained. Dark flow reminds us that the universe is not static. It moves, it whispers, it pulls at itself in strange and secretive ways. It is a current we cannot trace, but can only sense. Like a ripple on the surface of an unseen ocean. Perhaps one day, new instruments will sharpen our view, bringing clarity to this enigma. Until then, dark flow remains an echo from beyond the horizon, a reminder that even what lies hidden leaves its fingerprints on the stars. Among the many marvels revealed by the cosmic web, one discovery still takes astronomers' breath away: the Hercules, Corona Borealis Great Wall. Even the name suggests something colossal, something beyond ordinary scale, and indeed it is. This vast structure spans nearly 10 billion light-years across. To place that in perspective, if you traveled at the speed of light, the fastest speed allowed by nature, it would still take you 10 billion years to cross from one end to the other. This wall alone makes up about 11% of the entire observable universe. How could something so immense have formed? That is the riddle. According to current theories, structures of this size should not have had enough time to grow since the Big Bang. The universe is only 13.8 billion years old. Yet here is a structure almost as wide as time itself. It is as though we found a mountain range so enormous that it defied the very rules of geology. The Great Wall is made of countless galaxies, woven together into a single cosmic filament, a ridge of light threading across the sky. It dwarfs superclusters, dwarfs voids, dwarfs nearly everything we thought possible. For astronomers, its existence is unsettling. It challenges the principle of homogeneity, the idea that on the largest scales, the universe should look roughly the same everywhere. This wall is not uniform, it is an outlier, a reminder that the cosmos may be far more complex and irregular than our models predict. For the traveler who gazes at it, drifting beyond the void, it would appear as an almost unfathomable curtain of galaxies, stretching from horizon to horizon. Not a single object, but a continent of stars, so vast it redefines what large even means. In its presence, we feel small. And yet, there is wonder in that smallness. To stand before something that should not exist, and yet does, is to glimpse the creativity of the universe itself. The Hercules Corona Borealis Great Wall is not merely a structure, it is a question written in galaxies, a riddle spanning billions of light-years, and perhaps a clue to forces we do not yet understand. When we gaze at the Hercules Corona Borealis Great Wall, we are reminded of the universe's boldness, its willingness to exceed our expectations. And sometimes, that boldness leads us to wonder, what if even our entire universe is not all there is? Some cosmologists propose that after the Big Bang, the universe did not expand into emptiness alone. Instead, it may have formed bubbles of space-time, each a universe of its own. Our cosmos, with its stars and galaxies, would then be only one bubble, floating in a vast sea of others. This is the idea of the multiverse. Within each bubble, the laws of physics may differ. In one, gravity could be stronger, pulling stars together more tightly. In another, atoms might never form. Some universes might collapse quickly, flickering out like sparks. Others might expand forever, silent and cold. It is a dizzying thought that infinity may hold not only endless galaxies, but endless realities, each unique, each governed by its own rules. And what lies between these bubbles? Perhaps a kind of cosmic foam where universes jostle, stretch, and expand, forever separated by the fabric of space-time itself. Even if we could approach the boundary of our bubble, the space between is thought to expand so swiftly that no traveler could ever cross it. The multiverse, if real, is beyond reach. Yet the idea remains powerful. It offers an explanation for why our universe has the precise conditions that allow life. Perhaps it is not unique, only one of countless variations. We are here because this bubble happens to permit stars, planets, and beings who wander at the night sky. For the traveler, floating at the edge of imagination, the thought of other universes is both humbling and comforting. Humbling, because our cosmos may be only one verse in an endless symphony. Comforting, because in that infinity, possibility itself becomes boundless. Whether or not the multiverse exists, the dream of it reminds us that the universe we see may not be the universe entire. Beyond the edge of vision, beyond the horizon of physics, mystery continues, infinite as ever. No matter how powerful our telescopes, no matter how daring our ships, there will always be a boundary we cannot cross. This is not a failure of technology. It is a law of nature itself. The universe is expanding, and with every passing moment, galaxies at the farthest edges slip farther away. Beyond a certain distance, they recede faster than light can travel toward us. Their signals will never reach Earth. Their light will never grace our skies. They are part of reality, yet forever invisible. This means that even as time moves forward, we do not approach completeness. Paradoxically, the longer the universe exists, the more of it slips beyond our sight. Horizons retreat, and the cosmos guards its secrets more tightly. The observable sphere grows, yes, but what lies beyond it grows faster still, racing away from us into eternity. It is a sobering thought that much of the universe, perhaps most of it, is hidden not just today, but always. There are galaxies, clusters, maybe entire structures larger than the Hercules Corona Borealis Great Wall, vast wonders we will never glimpse, not even in theory. They are sealed off by the expansion of space itself. And yet, there is a strange beauty in this hiddenness. It means the cosmos will never be exhausted, never fully mapped, never entirely known. There will always be mystery, always questions unanswered, always horizons beyond reach. For the traveler at near light speed, the truth is the same. No matter how far they go, no matter how long they drift, there will always be more beyond. An infinity that stretches farther than thought can follow. Perhaps this is the universe's most gentle gift. Not answers, but wonder. To remind us that curiosity has no end. That even as we learn, there will always be more to dream of. That mystery itself is eternal. As vast as these mysteries are the voids, the walls, the horizons, we are still here, small beings on a small planet, gazing upward. And perhaps that is what makes it most profound. The universe does not need us to notice it, yet we do. When you step outside at night and lift your eyes, the stars you see are not just distant suns. They are fragments of this story. Each glimmer carries the weight of time, the memory of a journey millions or billions of years long. Each beam of light is a messenger, arriving at your eyes after traveling across the endless dark. To know that we live inside a cosmic void, or that the observable universe spans 93 billion light-years, is not meant to make us feel small. Instead, it should remind us that we belong to something immeasurably vast. We are woven into the same fabric as the galaxies, the same laws that bend light and time. The fact that we can even ask these questions, that our minds can reach beyond the horizon of our senses, is a kind of miracle. We are creatures made of stardust, gifted with the ability to wonder about the stars themselves. Perhaps we will never cross the void. Perhaps no ship will ever pierce the horizon. But still, in our dreaming, we have already traveled farther than our bodies could carry us. Imagination lets us step beyond limits, wander past horizons, touch mysteries with thought alone. And maybe that is enough. To gaze at the night sky, to listen to its silence, to let it carry us into sleep that is already a kind of journey. A voyage not through distance, but through wonder. And so, our voyage draws to an end. We have drifted from the quiet hollow of the KBC Void to the great walls of galaxies. From the boundary of the observable universe to the haunting thought of infinite others. We have touched the wall of light speed, felt time stretch and slow, and stood in awe of mysteries forever beyond our reach. Yet now, we return back to ourselves, back to this small world spinning beneath the stars. For all its vastness, the universe still greets us with intimacy. The same laws that shape galaxies also guide the fall of a leaf, the rhythm of your breath, the steady beat of your heart. Perhaps that is the truest wonder, that we, fragile and fleeting, are part of this cosmic story. We are not outsiders, gazing in. We are woven into it, written in starlight and silence, carried by the same currents that move galaxies across the deep. So as you close your eyes tonight, let the vastness be not frightening but soothing. Let it remind you that you are held in something immeasurable, that your story is cradled by the same universe that cradles the stars. Drift gently, as galaxies drift. Rest quietly, as the cosmos itself expands in silence. Tomorrow, the questions will still be there, waiting like constellations to be traced again. But for now, let wonder be enough. Thank you for traveling through the universe with me. If you wish to wander again, to explore, to dream, to listen to the stars, I invite you to return and to subscribe for more journeys like this. Until then, may your sleep be deep and your dreams as vast as the cosmos itself.